Okay, are you guys ready for it? This is velocity notes, which is also derivative, 12.4. And some of you guys have probably learned about velocity in physics, but we are going to make it even more simple. And guess what? Ta-da! That did not happen very good. It's supposed to be confetti. This is the last notes of your year. For your seniors, of your last math notes of your high school career. Woo! Sorry, confetti's not going good. But it is the last notes of the year. Yay! And for some of you juniors, maybe it's your last math notes of the year, your school year too, and your high school career. So we're gonna talk about it. Okay, so first of all, this is just a little review. This is where we started. We started with an equation with the limits. We were changing this value just a little bit to get to that. And then we had this two equations. And these are called derivative equations. Okay? And we use these in 12.1, and then we found a shortcut. Well, now, it's going to ask you it'll give you an equation, it'll ask you to go backwards, it'll have an equation all written out and ask you, what is f of x? What's the shortcut? Different shortcut than before, but the shortcut is that the last thing is f of x. So in this problem, f of x must have been x squared. So instead of looking out and solving this whole problem, if it's already written out for you, you just have to tell me what was f of x. So in this case, f of x is that number, and it's x squared. And it's always going to be a minus, because if you look back at this equation, it's always a minus here. We're always subtracting. So it should be a minus, and that's the answer. You don't have to raise anything, you don't have to do anything. So here's another one. What had f of x had to be? This last part. So the original equation must have been 5x squared minus 12x plus 3, and then we put the change with the x plus h in to get the answer. So you're going to see on the worksheet, it's just going to ask you to do a couple problems like that. Look at the last part. That's the original problem. Okay, so now we're going to go through velocity. So let's say, I know we can't travel right now, children plays, but let's say we're going Clovis to San Francisco. And let's say it's 240 miles away. And let's say on the way there, it takes us 4 hours to go there. On the way back, we hit traffic coming out of the city, and it takes us 6 hours. Okay, so let's talk about what's the average velocity. And velocity is basically our speed, so miles per hour. So we went a total of 480 miles, and we took 10 hours. So we went on the average of 48 miles per hour. Slow. Now, did I go 48 miles per hour? No, I go fast. But on the average, that's what we went to. Okay, so what does that have to do with us? Well, velocity function is simply the derivative of the position function. So it's the derivative at a certain place and point in time. So you're going to see this and this. They mean the same thing. VT means velocity, and it also means the derivative. Okay, so velocity, our derivative means slope, and it means velocity. In physics, it's velocity. Okay, so we're going to go through this, and when you guys get to the worksheet, there's a lot of different parts to it. So the first part is, it says write the position function, write the velocity function, or given the position function, write the velocity function, and find the velocity at the indicated time. So you understand t is time, whatever time it is. So we first need to find the velocity function. So we could either write s prime t or vt, it doesn't matter, they mean the same thing, and we're just going to use the power rule. 4t minus 4, t goes down to 0, no t's there. And then, so that's our velocity function. And at let's say 3 hours, we want to find what actually the velocity would be at 3 hours. We go 4 times 3 minus 4, or 12 minus 4, which is 8. And maybe that's 8 miles per hour, maybe that's 8 feet per second, and who knows what the thing is, but that's how you do it. So velocity is your derivative at a certain point in time. Okay, so we're going to do another one. We're going to find out 2 whatever hours, seconds, what the velocity is. So now here, we're going to take the derivative. Again, you could write like that. Oops. Or you can write like this. power rule, negative 3t squared plus 6t, don't forget there's a 1 there, minus 1. Constant number is nothing. Now we're just going to figure out 2. So we're going to find the velocity at 2. So negative 3 times 2 squared plus 6 times 2 minus 1. That's negative 12 plus 12 minus 1. So negative 1. Now you're like, how's a velocity negative 1? A velocity is direction and speed. So if your velocity is negative, that means you're going down that many feet per second. So you can have a negative in velocity. You can't have a negative in distance. You can't have a negative in speed. But you can have velocity. Velocity is direction and speed. Okay, so next thing is, what's the following function, position function, given the time when the velocity equals 0? So velocity equals 0 is when it's standing still. When is something standing still? Well, it depends on what it is. It's either before you threw the ball, when the ball hits the ground. If it's a particle moving in space, sometimes it moves, stops, bounces off, moves again. So there's a lot of different ways that it could equal 0. So what we're going to do is, it's velocity. So we're going to find the velocity function. Again, that is also the derivative. Power rule, negative 6t plus 24. And now we're not going to put a time in. We want this to equal 0, so we're going to set that equal to 0. And we're trying to find time, so we're trying to solve for t. Be very conscious of what you're trying to solve for. So t equals 4. Maybe it's 4 hours, maybe it's 4 seconds, but after, let's say it's seconds. After 4 seconds, it would be 0. Maybe that's when it hits the ground. And you'll notice a lot of these are negatives because this might be something going up and going down. Same thing on number 7. We're going to find the velocity function, which is the derivative. 1/3 times 3 is 1, t squared, minus 8t, minus 12. And we want to know when this is going to equal 0. Okay, now, again, sometimes things equal 0 more than once. This you're going to have to factor. So what multiplies to be negative 12 adds to be negative 8. We have a mistake here. You can't multiply to be a negative. This must be a plus. Let's change that to a plus, sorry. So that it factors right. So t minus 6, t minus 2. I notice I think on yours it's wrong too, so change that to a plus. And then figure out when these equal 0. So 6 and 2. So there's 2 times where it actually hits 0. So again, this is a cubic. Try to explain, so maybe it went up. So cubics look like this. So maybe it went up, hit a flat, it goes back up, hits a flat. Okay. Okay, so velocity equals 0. Always look at what you're trying to find. You're trying to find time, so you're trying to find t. You're making it equal 0. Okay, so now we're going to get, a lot of this is going to be word problems, and when you get to the review, a lot of word problems, and so they have a lot of points to it. So there's one equation and a lot of different information to it. So first of all, let's talk about the equation. I don't know if you guys know this from physics, but this negative 16 is a coefficient of gravity, so it's used a lot in word problems because that's how much gravity pulls things down. So this is the equation for a height of an object that's dropped from a 400-foot building. So it's not thrown up in the air, it's actually on top of a building and it's dropping. So you're on a building and you're dropping it off. Okay, so it starts up high, and as it goes, it's going to go down. We're going to relate this back to going from San Francisco to Clovis in a little while. So first of all, what's the height at 2 seconds? Okay, so if it's just asking the height, the position, use the original function. So all you do is find s of 2. So you plug 2 into the original equation. So again, anytime it says position or height, use the original equation. We only use the derivative if we're talking about velocity. So order of operations, that's 4. Negative 16 times 4 is negative 64. That's 128 plus 80. That's 64 plus 80, which is 144. And this time we know it's feet. So it starts at 400 feet high. After 2 seconds, it's dropped down and it's at 144. Okay. Now, after 4 seconds, it's going to be even closer to the ground, so we're going to plug 4 in. Again, this is the position, so use the position or the normal original equation. And again, remember this is going to be lower to the ground, maybe even hitting the ground. If you do the math here, 16 times negative 16 is negative 256. 64 times 4 is also 256. Plus 80, so you get 80 feet. Not hit the ground yet. So now it's farther down. Okay, so now going back to driving from Clovis to Fresno, we want to find the average velocity from 2 to 4 seconds. So at 2 seconds we were at 144, and at 4 seconds we were at 180, sorry. This is supposed to be 80. And basically you're going to find what we did from Clovis. You're going to figure out how far it traveled and how long it traveled. So how far did it travel? Well, it traveled down. So you got to be careful. It's basically, and you could do it however it traveled at 2 seconds. I'd rather start here. It's like slope x1, y1, x2, y2. So it's 80 minus 144. Because this is from 2 to 4, it's going down. So this is, and then it's 4 minus 2. So we went negative 64 over 2, or negative 32 feet per second. Again, this is in seconds. So that's the average velocity. Did it ever go that speed? I don't know, but on average, that's how much it went. And you could also do it backwards. You could do it this way. You could have gone 144 minus 80 over 2 minus 4 and got 64 over negative 2 and got the same answer. Okay, so velocity can be negative because this is going down. It's dropping, so it is going to be negative. Okay, so part D now. So we did A, B, and C. Write the velocity function, derivative, find the velocity at 4 seconds. So first thing was we're going to find the derivative. Remember this and this mean the same thing. Use the power rule. So we'll go up to this equation, negative 32t plus 64. And then, so that's the function we use anytime they ask us the velocity at a certain moment of time. Now, can you really find the velocity at a moment of time? Pretty hard. But we can kind of approximate it. So at 4 seconds, it would be negative 32 times 4 plus 64. And that's going to give you, that is a total of negative 128 plus 64, which is negative 64 feet per second. So the velocity at 4 seconds is negative 64 feet per second, if you can instantly stop time. Okay, and so why do we use a derivative? Because we can't actually find the exact time, we kind of use a limit. So when does this object hit the ground? Okay, well, how high is the ground? Well, the height of the ground is equal to 0. Now, does it have anywhere in here that's talking about velocity? No, never. So we're not using the velocity function, we're using the original function, and we're trying to solve for t. So we'll try to find when. So we are making this equation equal to 0 because that's the height of the ground. Now, pretty hard algebraic equation. I would take out a GCF, negative 16. That gives me t squared minus 4t minus 5. And then that's a pretty easy question to factor. So you get t minus 5, t plus 1, and you get 2 answers. T equals 5. And t equals negative 1. Now, velocity can be negative, but time can't be. You could say it hits the ground at negative 1 second. No. The answer would be just 5 seconds. So if you think about what we did, I'm just going to go back for a second. At 2 seconds, it's 144 feet. At 4 seconds, it's 80 feet. And at 5 seconds, it hits the ground. Now, what is the velocity impact? So if you guys know anything about gravity, as something goes down, it picks up speed. So it's also velocity is a slope, and the slope is going to be steeper as you get closer to the ground. So we have to go back to the velocity function, which remember was negative 32 t plus 64. And what's the velocity at impact? So all we're going to do is we know the impact is 5 seconds. So we're going to plug in 5. So that gives us, what's that? Negative 160 plus 64, negative 96 feet per second. The most velocity at any time. So be very close. So velocity, use the derivative. When's it hit the ground? Not using the derivative. Okay, next page. You're going to see another long word problem that, like I said, this is the last notch. Yay, hooray! But it's going to be long. When the object is dropped off of a higher building now, the height in feet and the time in seconds is given by this equation. Again, negative 16, giving you the coefficient of gravity, and we're going to do the same thing. So what's the height at 3 seconds? All we're going to do, we don't use the derivative, we use the original function, and we plug in 3. Do our math. 9 times negative 16 is negative 144 plus 480, 336 feet. Again, this is dropped off a building that's going down. At 5 seconds, it should be even farther down. So again, we're using the original function because it's asking us the object's height or position. Negative 16 times 5 squared plus 480. That's going to give you 20 times negative 16, which is negative 400 plus 480, 80 feet. Okay. So obviously sometime after this it hits the ground. Okay, so part C. After how many seconds does it hit the ground? Now, we're so used to things always being whole numbers, it doesn't have to be a whole number. So what's the height of the ground? It's 0. So we're going to make this equal to 0. Again, no mention of velocity yet, so we're not using a velocity function. And you can either factor this by taking a GCF, which is hard to do. I'm just going to solve. So I get t squared equals, that divides in, I think, 30 times, if I'm right. I think it's 30. Yeah, it is 30. And then I have to figure out t, so I'm going to take a square root. And like I said, not everything is imperfect, so if you take the square root, you get plus or minus in a calculator about 5.5 seconds. Again, you can't have a negative, so our time has to be 5.5 seconds. So again, remember, at 5 seconds, it was 80 feet above the ground, so in 5.5 seconds, it hits the ground. Okay, now what is the average velocity? So again, at 3 seconds, it was 336 feet. At 5 seconds, it was 80 feet. So what's our average velocity? And again, this would be a negative because it's going down. And I got negative 256 over 2, which is negative 128 feet per second. And this should make sense that this one's faster because it stopped from a higher building. Okay, now we're going back, and now you're going to see the word velocity. Yeah. So velocity, we are going to figure out the derivative. So the velocity function is the derivative. Power rule, negative 32 t, nothing there. What's the velocity after 3 seconds? Just plug in 3 seconds. That is negative 96 feet per second. After 5 seconds, just plug in 5. Negative 32 times 5, negative 160 feet per second. So if you guys remember, when we got the other one, the average velocity was 128. 128 is the average of those two numbers. So you could have added those two numbers, which gave you 256 divided by 2. Another way to do it. Okay, now last part. An object is dropped again, same problem. What is the velocity when an object hits the ground? Again, how high is the ground? The ground is this high, is 0. So you want to set it equals 0 and its velocity, so you have to use the derivative. So the velocity function again is negative 32t, and we're going to set that. Oh, sorry. And we know, it says what is the velocity, so we know when it hits the ground. We have to go back to part C. How many seconds does it hit the ground? We got 5.5, and we're going to plug it in. And when it hits the ground, it's negative feet per second. So you had to go back, figure out when did it hit the ground, and use that to plug into velocity. So this is the highest one we have, because when it hits the ground, it's at the highest speed. You are done. You will see this worksheet, you will see the review worksheet, and then there's a homework quiz, and the homework quiz is basically something I'm not going to help you on, and that is basically your test that you understood this. It's not worth that many points, but it's I don't want to help you on that part because I want to make sure to see what you know. Good luck. Gonna miss you guys. Bye.